had to split this video up due to the file size causing editing issues. But to quickly recap, supplementing vitamin C impairs the uptake of copper and zinc, and this has horrible effects on your redox status, your antioxidant status. For that matter, so do glucose and fructose, especially in large amounts. Vitamin C also degrades into oxalates, and oxalates cause cancer and many other problems in the body.
Okay, here we go. The short version. Do you?
Yes.
Do you?
Yes.
Here we go. There. This thing isn't worth the gold it's made of.
And vitamin C, at least in these doses, is harming you on a cellular level. And I believe it is due to the production of oxalate, which impedes proper metabolic function in cells. In my video about allulose, I talked a bit about why I would never knowingly take something that blocked the glucose uptake transporters, and here is a case in point. Glucose and fructose actually block the absorption of copper in a dose-dependent manner. In animal studies, it rapidly causes copper deficiency, and this means ceruloplasmin levels also decline. And ceruloplasmin is the main antioxidant that counteracts iron in the body. If you're low on ceruloplasmin, cancer, accelerated aging, and many other issues are going to occur. In fact, since vitamin C also uses the GLUT transporters to enter the body, it also competes with tons of other nutrients for absorption. It's also shown to lower copper absorption in the body and to directly lower ceruloplasmin. However, for most people, there's too much copper, and copper will block zinc in the diet. More copper intake does not increase ceruloplasmin levels if you're not deficient. So copper supplementation is a bad idea for most people. This would mainly be an issue for people with severe metabolic syndrome and a very poor diet full of tons of carbs and very little animal fat. For most people, supplementing copper will do more harm than good because this is going to reduce your zinc absorption, and zinc is almost important as ceruloplasmin for your body's antioxidant status. And keep in mind that zinc deficiency is strongly associated with type 2 diabetes. So while I did not find a specific study to back it up, it's also probably going to be blocked by glucose, fructose, and vitamin C, and also allulose for that matter, because it shares the same absorption pathway. While some people have disappointingly portrayed Linus Pauling's vitamin C promotion as egoism, quackery, or even dementia, in reality it made perfect sense with the imperfect knowledge he had in the 60s and 70s. And that's when he formed these ideas and promoted them. He did write a book in the 80s, but it was just a summary of what he had already been promoting for at least 20 years by then. At the time, it was believed vitamin C was the main antioxidant of the body, and since humans couldn't produce it internally, it was absolutely vital to have as much as possible in the diet for human health. However, while it's true that almost all mammals produce massive amounts of vitamin C daily, this isn't true of humans, and for a very good reason. We don't need it. Only in 2008 was it discovered that humans have an amazing capacity to recycle ascorbic acid, and in reality we are very poor at absorbing it in the diet. DHAA, on the other hand, or dehydroascorbic acid, the oxidized form that's found in meat and other animal products, is absorbed thousands of times more readily than ascorbic acid is. Fresh meat and seafood have all that we need, and in spite of what some say, vitamin C is not destroyed by cooking. Instead, it's oxidized, and it's oxidized to what form? Can you guess it? Dehydroascorbic acid. And that's the form we can actually absorb and use in the human body. Though some carnivore diet advocates have speculated the reason vegans need more vitamin C is that glucose competes for its absorption, that's really not the case, and I don't think the vitamin C is doing them any favors. It does slow down the absorption, but the amounts that you're going to be getting eating fruit is just way more than what the body needs. And the human body just doesn't use vitamin C well as an antioxidant. It has many drawbacks. While it's true humans don't make vitamin C, oxidative stress is still a main driver of aging and longevity. Yet somehow humans live much longer than most animals, so this presents a paradox. Humans are worse than every animal when it comes to vitamin C, and yet they live longer. Why? That's largely because humans have a much more sophisticated antioxidant system in their bodies than animals do. Some of the simplest animals do show some moderate lifespan increase from supplementing vitamin C, but the longer lived the animal, the worse the results are. And even a simple mouse shows no benefits. The naked mole rat, on the other hand, which lives for 30 years, has its lifespan decreased by around 25% by supplementing vitamin C. For humans, glutathione is the most important antioxidant, along with ceruloplasmin, but we also have a lot of other ones that are not really that important in other animals, such as uric acid, which is actually a big antioxidant. And having it in your bloodstream is actually not a big problem. It's only a problem when you have it in your joints, and this mainly is driven by liver failure. Glutathione requires both glycine and cysteine to be manufactured in the body, and both of these are lacking in plant-based foods, and they're also lacking in most people's diets today. Glycine is lacking even in meat eaters because today fewer and fewer people consume broth daily, even though it was typical just a few decades ago. There's another issue with glycine in that it is very similar in structure to glyphosate, and if glutathione or ceruloplasmin is made with glyphosate instead of glycine, it will not work properly, and this is going to lead to cancer and aging and many other problems. That is part of why glycine is a very important supplement, because it can outcompete these poisons and stop this from happening. And because glyphosate is basically everywhere, so even if you're eating organic food, you're probably getting some glyphosate in there. You also require cysteine to create glutathione, which is present mainly in animal protein. That is probably why people on a keto diet are shown to have double the glutathione levels as the average person. For vegans, this level is going to be much worse, and they are probably going to have low levels of ceruloplasmin as well, for reasons already stated, which is going to make things even worse. That's probably why you see a lot of vegans having early gray hair and very bad skin. To get at cysteine, your body splits apart methionine, which is why methionine is such an important amino acid in the body. Unfortunately, this is where homocysteine comes from, and this is a harmful byproduct in the body that increases inflammation, heart disease, and cancer too. However, you require it to make glutathione and taurine, and actually a lot of things in the body that have anti-aging and antioxidant benefits, so it's not an optional thing. But in order to reduce or eliminate homocysteine production, you can take the supplement L-cysteine, which creates cysteine for these processes without the harmful step. You can also take taurine as a supplement, which negates the need for the body to make it, and this will also drive down your homocysteine. I take 6 grams of taurine and 6 grams of glycine and 1 gram of cysteine per day. And you can find a list of many other supplements I take in the description, as well as instructions on how I take them. Zinc is also critically important as an antioxidant and for gut health. It also increases metallothioneins, which are what your body uses to bind up heavy metals for removal or for safe storage away from the organs. This is of similar importance for your health as cleaning up the damage of oxidative stress. So if this is being pushed low, then this is a big problem. Unlike copper, most people today probably are deficient in zinc. In fact, I'd say almost everyone is. That's because it's easily blocked by plant-based foods, especially coffee, and most people seem to drink coffee constantly today. It's also blocked by copper, and to some extent by glucose and fructose, and nuts are basically going to block it too. In fact, in general, if you want to avoid vitamin deficiency, then reduce carbs in the diet as much as possible, as well as anti-nutrients from grains, nuts, and legumes. And that's the only way that you're going to stop this. And there may not be a study for everything that's blocked, but since so many things use these same transporters, it's all going to be impeded by not only the anti-nutrients, but simply by the glucose and the fructose. That's going to stop you from absorbing nutrition. And shockingly, so will vitamin C. And it also has the minerals in the wrong proportions in these plant foods, and that's also going to cause big problems. So you might consider that next time you have some baked goods.
It's gonna kill you!
I've had a good run.
Now that we can see vitamin C supplements are essentially metabolic poison that block nutrients and have the opposite effect on antioxidant status, as you might expect, should we even take it at all? Now, I don't think we should take a supplement for most situations, but we do have one thing that vitamin C is critical for in our diet in small quantities, which fortunately can be fulfilled by dehydroascorbic acid, and that's hydroxylating proline to make hydroxyproline in collagen. This is not the same as hydrolyzed collagen, which is just collagen broken down to peptides. This is adding a hydroxyl group to proline, which is basically a water molecule without one of the hydrogens. This makes collagen less brittle and more elastic and stronger. And you do need it because you cannot absorb whole collagen. It has to recreate it inside the body after digesting. Thankfully, we don't need very much for this purpose, and it's probably just 2 or 3 milligrams. The savvier vegans like Dr. Greger actually do understand that the antioxidant status of plant eaters is worse than that of meat eaters, and this is the main reason they promote vitamin C so heavily. Greger has some very old clips discussing this, which I've run across a couple of times. They think they can make up for this issue by taking lots of vitamin C, but unfortunately this just doesn't work out in practice, and neither vegans nor carnivores should supplement vitamin C. A few milligrams is all the body really needs, and anything beyond that just causes excessive damage from oxalates and nutrient absorption issues. Vegans also try to scare people with the specter of scurvy, just like they'll tell you liver is highly toxic. Why they have to scare people off from quality nutrition as if it were deadly poison is highly puzzling. But there's no case in history of someone dying of vitamin A poisoning from eating beef liver. There's also thousands and thousands of carnivores today who eschew all plant products and they don't have scurvy. Explorers and soldiers in the Age of Sail did suffer from scurvy, but they ate mainly hardtack, which has no vitamins at all, and salted pork, which rotted away or ran out very quickly on these ships. Interestingly, explorers from the Nordic countries did not have this problem, probably because they ate large quantities of well-preserved fish instead of what the English ate.
We get loose connective tissue, we get low-grade, weak collagen, and it breaks down. Our gums start bleeding, our arteries and vessels start tearing, get our arterial dissections and all these sorts of things, and you die. It's very dangerous. British, they're called limeys because they gave their sailors a whole bunch of limes because they started getting scurvy.
Mm-hmm.
But they started getting scurvy. It wasn't that everyone was getting scurvy and the British were the ones that figured it out. We've been seafaring people for thousands of years, and it was only the British in the last few hundred years that started getting scurvy. Where the British officers were not getting scurvy because British officers were being fed meat, and the sailors were the ones just getting gruel and porridge, things like that.
Okay.
And so they weren't getting enough vitamin C. And so then you look at the polar explorers, again, living with the Inuit, who aren't getting citrus or anything like that.
Mm-hmm.
They're just eating meat. The polar explorers that ate like the Inuit did and just ate meat and fish and blubber, perfectly healthy. I mean, the books written about it like Wilhelmer Stefansson called The Fat of the Land. They said they've never been healthier in their entire life. And then some people, there are accounts of people in those exploration groups who didn't eat that way and were like sneaking in like sailors biscuits and crackers and bread and things like that. And they were the ones getting extremely sick and nutritionally deficient and almost dying. And then they found their stash of food and they threw it out and they just gave them meat and they just recovered.
Does this mean it's medically useless? Not necessarily. Keep in mind that most medications have a lot of side effects, probably way more than vitamin C. And if you take them long enough, most of them will actually kill you. Sometimes when your antioxidant status is very impaired, such as when ill, then directly adding it to the body might be helpful, but you will still get all the drawbacks of vitamin C when you do this. So zinc, glutathione injections, or vitamin D, or another antioxidant is probably a much better choice. And if you keep carbs low and get plenty of meat in the diet, your antioxidant status is going to be very good in the first place, especially compared to vegans, but it's going to be about twice as good compared to the average diet too. Your immune system will be very good too, so you're much less likely to get sick in the first place and you probably just don't have to worry. In the words of the guys from Mythbusters, science is just writing stuff down while messing around. It's a process of testing and experimentation, which could be characterized as informed trial and error. Theories can never be proven, in spite of what some hilariously misguided YouTubers claim. Science isn't Schoolhouse Rock, and you can't promote a theory to a fact, but the data itself is factual, or at least considered as such if there's no evidence of fraud or error, much like whatever the police say is usually considered as fact, unless it's proven that they were lying. Theories must always yield to fact and be postulated based on fact, but due to corruption and bias, many scientists find it difficult to reject their theory when the experimental results just don't agree with what they want. And the worst ones like Ancel Keys will actually suppress data that doesn't fit their theory, and even attack and destroy the careers of people who disagree with them, which he was very famous for. Unlike Keys, Linus Pauling was a great scientist, but he was a great scientist of the 30s and the 40s, and to some extent the 50s, and he didn't have access to the same facts we do today, and these facts simply debunk his theories about vitamin C. Our ancestors ate almost all meat for about 1 million years, at least by percentage. They did eat whatever they could find, but there wasn't much else to find. And this only changed in the last few thousand years. Even in the time of classical Greece, bone isotope analysis shows that plant foods only constituted a tiny percentage of the total human diet. Plant foods are not required for human sustenance, and the little vitamin C we need is easily found in fresh or cooked meat and seafood of all types. This is in the form of DHAA, or dehydroascorbic acid, not to be confused with DHA, which you need for your brain. And this is absorbed 100,000 times more readily than ascorbic acid, which is what we call vitamin C. Unlike animals, we have an extremely advanced antioxidant system, and supplemental vitamin C greatly impairs this by inhibiting nutrient absorption and increasing oxalates in the body, which is not only bad for the kidneys, but also is a metabolic toxin that impairs cellular respiration and leads to cancer. Vitamin C, glucose, and fructose all lower absorption of copper and reduce ceruloplasmin in the body, which lead to a worsened antioxidant state. So in practice, this antioxidant has the opposite of its intended effect, and so do the foods that contain it. This is especially true at high doses. In fact, these same culprits will impair the absorption of a wide variety of nutrients, not just copper. Vitamin C also degrades into oxalate, which is shown to cause lung cancer and will impair ATP production in the body, and which is going to have widespread consequences for health. As often seems to be the case, the opposite of the advice promoted to us by corporate science is the real truth. It is a low-carb diet that will increase antioxidant status, and that is why a keto diet leads to twice as much glutathione in the body. We can also take supplemental glycine, L-cysteine, and taurine to further augment our antioxidant status as well. And these are almost wholly lacking within the plant-based kingdom. But if you want to age yourself and become nutrient deficient, then plants and vitamin C are the way to go. Of course, if you want to be healthy, the dietary solution is clear.
A, B, C. A always B, B, C.
Crockpotting.
Always be
Crockpotting. Always be crockpotting.